Hi everyone! In this video we're going to learn how to graph trigonometric functions using horizontal translation. Let's look at this example. We will need to graph one cycle of the function y equals cosine of 2 over 3x plus pi over 4. I know that the method of horizontal translation can be applied here because of this number that's being added right next to x inside the parentheses. And generally this is going to be the case if you can see number being added or subtracted inside the function, in other words right next to x, and the graph of this function can be obtained by shifting the basic graph to the right or to the left. So let's look at the steps. What basic graph am I talking about? That's going to be a graph of the function that does not have this extra number that's being added or subtracted, in our case, that doesn't have plus pi over 4 inside the parentheses. So we start by graphing the function y equals cosine of 2 over 3x. Let's collect all the necessary information. The amplitude of the graph corresponds to the number that's right in the front of cosine or sine. Well, this number is 1, that's why it's invisible. So the amplitude is 1. Is this a reflected graph? No, it's not. We know that it's reflected when there is a negative sign in the front of cosine or sine. Frequency of the graph is 2 over 3, that's the coefficient of x. And finally, to compute the period of the graph, we're going to take 2 pi and divide by the frequency. So that is same as 2 pi over 1 multiplied by the reciprocal of the denominator, so 3 over 2. It's 3 pi. Now I have all I need to sketch the graph of this basic function. I'm going to place the period 3 pi on the horizontal axis. That's where the first cycle is going to end. And I'm going to split that segment into 4 equal parts. Each of these places will correspond to one of the key points of the basic graph. So the first one is always 1/4 of the period, so 3 pi times 1 over 4, that's 3 pi over 4. And since all subsegments of the same length, I'll keep adding 3 pi over 4 to obtain the rest of the labels. 3 pi over 4 plus 3 pi over 4 is 6 pi over 4. Then it's 9 pi over 4 and 12 pi over 4. Okay, so I can see how 12 pi over 4 is same as 3 pi, so that checks. And then I'll obtain the simplified versions of all fractions. 6 pi over 4. It's same as 3 pi over 2, and 9 pi over 4 in the simplest form already. So these are the x values that we need to graph the basic function. Now I can erase all that scratch work. Next, I'm going to label the vertical axis. We said that amplitude is 1. So I'm going to place 1 and -1 on the vertical axis. And I'm ready to start plotting the points. Since we're given cosine function, and it's not reflected, the first key point that's on the vertical axis will be the maximum point, right here. Next point is 0. After that, it's the minimum point, back to 0, and then maximum point again. So here I have one cycle of this basic function y equals cosine of 2 over 3x. Notice that I use dashed line, well, just because it's not our final answer. What we have here is the graph that we're going to shift to obtain the graph of the given function. And the question, of course, is which direction we have to shift it and how far. We're going to find that in the second step. In the second step, we're going to determine what's called the phase shift. That's basically the direction and amount of the horizontal translation. Which direction and how far. And this is what we need to do to find the phase shift. We're going to take the entire expression that sits inside the parentheses in our function, and we're going to set it equal to 0. So 2 over 3x plus pi over 4 equals 0. And now we need to solve this equation for x. And we're going to perform all standard steps for getting x by itself. So first we're going to subtract pi over 4. from each side. So 2 over 3x equals negative pi over 4. And now to get rid of the fraction that's in front of x, I'm going to multiply by its reciprocal on the left and on the right. When I multiply reciprocals, the result is 1, so on the left I just have x. And on the right hand side I obtain 3 pi over 8. And that's going to be the phase shift. The meaning of the result is that the graph of the basic function that we obtained has to be moved 3 pi over 8 units to the left. So this negative sign indicates that the direction of the shift is to the left. Okay, so now we know if we take all those key points and shift them 3 pi over 8 units to the left, we're going to obtain the graph that we need. But the question is, where do I place them along the horizontal axis? When I work with the fractions, it's not that intuitive as when we work with the whole numbers. So to identify the exact location of the shifted points, we're going to perform step 3. In the first column, we're going to list the original x values, and that refers to the x values of the key points of this basic graph. Each cycle will always contain 5 of those points. So in this case, it starts with this maximum point and it corresponds to 0. And then we're going to write the x values that are labeled here. 0, 3 pi over 4, 3 pi over 2, 9 pi over 4, and then 3 pi. How do we compute the shifted x values, or the new x values for the key points after they got shifted? Well, in step 2, we found that the phase shift, or direction and amount of the shift, is negative 3 pi over 8. So to calculate the new positions of all these key points, I have to take their current position and subtract 3 pi over 8. So let me write this all down. Okay, so that's what I got. Now let me compute each value one by one. So the first one is easy, it's just negative 3 pi over 8. For the second one, I have to obtain same denominators. So that's 6 pi over 8 minus 3 pi over 8. That gives me 3 pi over 8. I'm going to box the final answers. 3 pi over 2 minus 3 pi over 8 for the third point. Here I'll have to again adjust the first fraction. So it's 12 pi over 8 minus 3 pi over 8. That is 9 pi over 8. Point number 4. That's 18 pi over 8 minus 3 pi over 8, so that gives me 15 pi over 8. And the last one, 24 pi over 8 minus 3 pi over 8. That's 21 pi over 8. Okay, so we found the x values of the shifted points. That's where we have to place them. But we still have a problem. For example, if I look at the new position of the second point, which is right here, that's this 0. Right now it's at 3 pi over 4, but according to my table, now it has to be at 3 pi over 8. And I'm still not sure where to place 3 pi over 8. Same for the third point, this minimum. I know that now it has to be at 9 pi over 8, but where is 9 pi over 8? Well, this is what we're going to do. The reason why I'm still not sure where to place the shifted points is because these fractions that I'm dealing with have different denominators. So what I can do to help me identify these new places is by looking at all fractions such that they have same denominators. I'm going to make a note for myself to show how these numbers that I already have labeled on the horizontal axis are going to look like with the same denominator as the shifted x values, in other words, denominator 8. So the first value, 3 pi over 4, is equivalent to 6 pi over 8. I just multiplied the top and the bottom by 2. The third one is equivalent to 12 pi over 8. I multiplied the top and the bottom by 4. Third one is 18 pi over 8. And the last one is 24 pi over 8. And now I can see where to place the shifted x values, because if this is 6 pi over 8, and I need to place 3 pi over 8 on the number line, well, it now makes sense that it should be just halfway in between. Let's try it with the next value. We need to place 9 pi over 8. Well, if this is 6 pi over 8 and this is 12 pi over 8, then 9 pi over 8 will be right in the middle again. And guess what? The fact that they both were right in the middle between the original x values is not the coincidence. You're going to have the same pattern for all new x values. Because of the symmetry that exists in the graph, and because we're shifting all points by exactly the same amount. So once I notice that pattern, so all new values are right in between the original ones, now I can just place them. So 15 pi over 8 is going to be here, and 21 pi over 8 will be here. And the only one that I haven't placed yet is negative 3 pi over 8. But placing negative 3 pi over 8 is going to be very easy, because it's going to be to the left of the vertical axis where all the negative values are, and it's going to be the same distance away from the vertical axis as 3 pi over 8. So I'm going to place it over here. I'm going to erase all the scratch work that I had to use, and I'm ready to shift points. This is going to be step 4 in this process. It's important to shift all points straight to the left. That's where it's going to be the 0. Then the minimum point will be at 9 pi over 8. Next 0 is at 15 pi over 8, and the maximum is at 21 pi over 8, so right here. As you can see, I'm not changing the shape of the graph, I only shifted to the left. Once the key points are shifted, I'm going to reconnect them to obtain the graph. And that's what I got. So what I have in red, that's the final answer, and that's the graph of the function y equals cosine of 2 over 3x plus pi over 4. And one last note that I'd like to make, and that's maybe something that you already know from algebra, is that when we perform horizontal shift, horizontal translation, or we also call it horizontal transformation, the direction of that shift is always opposite to the sign that you see inside the parentheses. So if number is added, the shift will be to the left. If number is subtracted, the shift will be to the right. So it's counterintuitive. But be careful, because while signs always work this way, the amount of translation is not necessarily the number you see there, right? Notice how we have plus pi over 4. However, the phase shift was 3 pi over 8. So be sure to perform all the necessary calculations as it was shown in step 2.